Okay, so today we're going to be able to write any number in standard form. It's about a grade 4/5 skill. Now, standard form is commonly used for numbers that are very large or very small, although any number can be easily written in this form. It makes use of the laws of indices, but numbers are only written using one power, 10. This is what numbers in standard form will look like. It will be a value a multiplied by 10 to the power of a number. But the important thing is that a, that value, has to be between 1 and 10. Here are some numbers written in standard form. Now we use this for really large numbers, like this one, 675 quintillion 400 quadrillion. And what I'm going to do to write this number in standard form is, first off, I'm going to put a decimal point between the 6 and the 7 and pretend that it is a number between 1 and 10. And what I'm going to do is I'm going to count how many times I would have to move that decimal point to get it to the end. Now you see, every time I'm moving this decimal point, it is effectively the same as multiplying it by 10. So here, to get the decimal point from here to here, I would have to multiply it by 10 17 times. So I can write this number in standard form as 6.754, the number between 1 and 10, times 10 to the power of 17. Now obviously the reason why we write these numbers in standard form is that this is a lot smaller and easier to understand than this large number, even though their value is the same. So for this one, again, I write it as a number between 1 and 10, 4.371. I count how many times I'd have to move the decimal point to get it to the end, 14 times in this case. So I call it 4.371 times 10 to the power of 14. Here with these two, again, I write it as a number between 1 and 10, so I'll call it 7.5. I count how many times I'd have to move my decimal point to the end. In this case, it will be 7 times. So I'll call it 7.5 times 10 to the power of 7. Here for this one, again, write it as a number between 1 and 10, 5.12. Count how many times I'd have to move my decimal point to the end. It'd be 8 times. So I'll call it 5.12 times 10 to the power of 8. Pause the video and have a go at these questions. And here are the answers. Now, let's pretend I've got a number in standard form and I want to write it as a regular number. So for 6.23 times 10 to the power of 5, what I'm going to do first is I'm going to write out the 6.23. Now, because I'm multiplying it by 10 to the power of 5, I would effectively be moving that decimal point to the right 5 times. So that's what I'm going to do. My decimal point will move from here to here. In here, all I then need to do is place in my zeros, and that tells me that 6.23 times 10 to the power of 5 is 623,000. 8.7 times 10 to the power of 7, write out the 8.7. Move my decimal point 7 times. Decimal point will end up here. Fill these gaps with zeros. And there's my number, 87 million. Commas aren't necessary for your answer. I've just included them for clarity. Here, 8.4 times 10 to the power of 4. I write out the 8.4. I'm going to move that decimal place to the right 4 times. Fill in any gaps with zeros. That tells me it's 84,000. 1.25 times 10 to the power of 8. It's 125 million. Pause the video and have a go at these questions, please. And here are the answers. Now let's have a look at really small numbers. Say this number, for example. To write this in standard form, okay, I'd still sort of want to use the number between 1 and 10, 4.26. But being as this time, to get the decimal point from where I've put it to where it should be, it would end up involving a lot of dividing by tens. Now, the advantage we've got is that you can use negative powers. 10 to the power of negative 1 is the same as a tenth. 10 to the power of negative 2 is the same as a hundredth, and so on and so forth. And what it is that because dividing by 10, for example, which is what you're doing when you're moving the decimal point to the left, being as that is the same as multiplying by a tenth, it's effectively the same as multiplying by 10 to the power of negative 1. Dividing by 10 is the same as multiplying by 10 to the power of negative 1. Dividing by 100 is the same as multiplying by 10 to the power of negative 2. Dividing by 1,000, 10 to the power of negative 3. What it means is that for numbers less than 1, between 0 and 1, I can write them in standard form using negative powers. So back to my example here. I call it 4.26. I'm going to count how many times I'd have to move the decimal point to get it from where I've put it to where it should be. And each one of these is just like by multiplying by negative power. So if I'm moving the decimal point 15 times to get it from there to there, I call it 4.26 times 10 to the power of negative 15. For this one, I put the decimal point between the 5 and the 8 to make it 5.83. I'd have to move the decimal point 11 times to get it from where I've put it to where it should be. So I call it 5.83 times 10 to the power of negative 11. Here, I treat it as 3.1. I'd have to move the decimal point 9 times to get it to where it should be. So I call it 3.1 times 10 to the power of negative 9. Here, I call it 4.685. I'd have to move the decimal point 10 times to get it to where it should be. So I call it 4.685 times 10 to the power of negative 10. Pause the video and have a go at these questions, please. And the answers? Okay, and finally then. Let's say I wanted to write 5.77 times 10 to the power of negative 3 as an actual number. So I'm still going to write out the 5.77, but because the power is 10 to the power of negative 3, I'm going to move this decimal point left 3 times. 1, 2, 3. The decimal point will end up here. What I'm going to do is with this gap here, I'm going to fill in zeros. But because this time I will also need something in my units column to the left of the decimal place, I'm going to put a 0 in my units column as well. For 4.2 times 10 to the power of negative 6, again, I write out my number, I'm moving my decimal 6 times to the left, it'll end up there, fill my gaps with zeros, include a 0 in the units column, so it's 0.0000042. For 9.5 times 10 to the power of negative 2, again I write out the 9.5, I move it to the left twice, it's going to go there, I'll need a 0 in the gap here and a 0 in my units column, so it's 0.095. For 6.1 times 10 to the power of negative 4, again, fill in my gaps with zeros, include a 0 in the units column, so it's 0.00061. Pause the video and have a go at these questions, please. And finally then, the answers for this.